Morning, guys. I'm sorry not to be with you, but I just thought I'd do a quick video clip to go through some of the PR that you did last night. Starting at page 3. So if you turn to page 3 in your handout, so that's question 4, as you can hopefully see on the board. If we look at question 4a, we're asked to find the area of both triangles A and triangle B. So area of a triangle is base times height divided by 2. So if we look at the first one, that's base times height divided by 2. So what does that give us? That gives us 4x squared divided by 2, which is obviously 2x squared. So you can either tick your answer, assuming it's right, or if it's wrong, then put in the correction. Then if we look at the second one, this is slightly harder. They've given us the hypotenuse here, but it is a right-angled isosceles triangle. So if we call each of the other sides y, what do we know? We know that the area of the triangle is y times y divided by 2. So that's y squared over 2. Now, what do we know about y squared? Well, using Pythagoras, we know that y squared plus y squared must equal 2x all squared. So 2y squared equals 4x squared. So therefore y squared equals 2x squared. So if we now go back to our expression for the area, which was this one here, if we just halve our 2x squared, we've got our expression for the area of that triangle in terms of x, as required. Okay? I'll give you a minute to get down any corrections on that. And if you're not sure, there are definitely some people that I went through this yesterday, so they should be able to explain it. Okay, so whoever's taking this lesson, I'm sorry. You can always pause this and give anyone who's certain that they understand it a chance to explain to those who don't. Okay, moving on to the second part of question 4. Okay, so here we are, the second part of question 4. Once again, right-angled isosceles triangle, and let's see what that actually means. Okay, if it's a right-angled isosceles triangle, we know that this angle here must be 45, as must this one here. Equally, we know that these are right angles, so that means that each of these other two angles must also equal 45. How does that help us? The way that helps us is that, therefore, these are also right-angled isosceles triangles. So we now know that each of these lengths here are 1 centimetre. So we now know that the hypotenuse of the triangle is 4. Okay, so again, if we call our two equal sides y, so here and here, as in the previous question, what do we know? We know that, y squared plus y squared must equal 4 squared. So 2y squared equals 16. So y squared equals 8. And by the same token, we also know that the area of that triangle is our base, y, times our vertical height, y, divided by 2. So it equals y squared over 2. Therefore, the area of the triangle, fairly obviously, must equal 8 divided by 2, which equals 4 centimetres squared. Okay, once again, I will give you a minute to think about what I've done, put in your corrections, and we can move on to the next question, which is question 2. Okay, the first few parts of this are jolly easy, and you shouldn't really have struggled with this. So we're asked to expand the brackets and simplify. So what do we get? Y times y, giving us y squared, y times positive x, giving us plus xy, minus x times y, giving us minus xy, and minus x times positive x, giving us minus x squared. So obviously the xy's cancel each other out, so we get y squared minus x squared. Okay, and then part B. They say if a and b are positive whole numbers, find all pairs of values of a and b with a greater than b that solve the equation a times b equals 35. So all they're really asking here is what are the factors of 35? Where you can't have a less than b, so you can't have the same two factors in reverse, is all they're saying there. So working this through, what can we do? We can do 35 times 1, where obviously 35 is a and 1 is b, and we can do 7 times 5, again, where 7 is a and 5 is b. Then we go on to the actual diagram C. So I'm just going to pause this for a second and do the diagram. So bear with me. Okay, here we are. In the quadrilateral shown, A, B, C, D, actually I better put those in. A, B, C, D. The angles A, B, C and CDA are both right angles, as shown. The side BC has length 1, and the side CD has length 6 even. Let AB equal Y and AD equal X, where X and Y are both whole numbers. Okay, so first up we're asked to use Pythagoras' theorem to show that y squared minus x squared equals 35. So what you had to spot here was, if we draw this line in from A to C, mine isn't very straight, but what you'll spot now is we've split the quadrilateral into two separate right-angled triangles which share a hypotenuse. Yeah, so there, that's the hypotenuse of ABC, and similarly, the same line AC is the hypotenuse of triangle ACD. So we can now form an expression using that, because we know that 1 squared plus y squared, i.e. AC squared, is the same as 6 squared plus x squared. Okay, let's rearrange that. So what do we get? We get y squared minus x squared equals 6 squared minus 1 squared, giving us y squared minus x squared equals 36 minus 1, 35, as required. Okay, now use your answers to part A and B to find all possible values of y plus x. Okay, so y plus x is obviously going to be the bigger of the two numbers, or of the factors that we worked out in part B. So therefore y plus x could equal either 35 or 7. Okay? Because clearly we can't have a negative value for either of those. Okay? Now, by finding the corresponding values of y minus x and using simultaneous equations, find all possible pairs of values for the length of side AB and AD. Basically, what that means is y minus x, well, when y plus x is 35, y minus x must equal 1, or when y plus x equals 7, y minus x must equal 5. And they give us a hint on how to use this. They say, using simultaneous equations, find all possible pairs of values for the length of the sides AB and AD. So I'm just going to move this up a bit to give me a bit more space. Just bear with me. Actually, I want to move the whole lot. Hang on. Let's move him up there. Let's move all these up there. Okay? So, let's now do our simultaneous equation. Let's do the first one, where we've got 35 and 1. I'm going to do this in red just so that you can see the difference. So we've got y plus x equals, 35, and y minus x equals 1. Okay? I'm going to add these two equations. So what do I get? I get 2y equals 36. Therefore y equals 18. And substituting that value into either of the two equations above, I can therefore safely say that x must equal 17. And if we do the second one, you've hopefully already spotted that's just going to work back to the original answer that they gave us earlier on. So that's going to be y plus x equals 7, and y minus x equals 5. Again, I'm going to add these. So what I get 2y equals 12, therefore y equals 6, and therefore x equals 1. Okay, it actually looked much harder than it was. I'm going to give you a bit of time to digest this, and I think that's probably, you've listened to me enough. That's all I'm going to go through for the moment, and the rest I'll go through, weather permitting, tomorrow. Once again, sorry to not be with you, and many thanks to whoever is taking this lesson. Hopefully this will make life a bit easier for you.